Hi, welcome to my channel. In the previous video, we discussed about what is machine learning, and what are the different types of machine learning algorithms. Machine learning algorithms like supervised learning algorithm, supervised learning algorithm. Second one is unsupervised learning algorithm, unsupervised learning algorithm, and third one reinforcement learning algorithm. Reinforcement reinforcement learning algorithm. So in this video, we are going to see some data set in order to perform the supervised learning algorithm. So here the data set is going to use here is MNIST data set. So MNIST data set is nothing but simply it is called as a modified National Institute of Standards and Technology. So it provides some data set. It's a simply it contains some 70,000 small images of digits of handwritten by the high school students and the employees of the US Census Bureau. So simply it is an digit, like it may be 5 or 1 or 0, like that what it may be there. So you have to collect the different 70,000 images, small handwritten digits. So each image is labeled with the digit it represents. Okay. So for example, here we are having the some sample images are the like 5, 0, 4, 1, 9, 2, 1, 3, 1, 4 like that. We are having the different types of images are there, handwritten digits are there. So now this set has been studied so much that is often called the hello world of the machine learning. So that means here whenever you have to perform some machine learning algorithm, we are going to use the MNIST dataset as a basic dataset in order to perform the classification. Okay, so that's why this is a one of the hello world of the machine learning programming. So it is a simple understanded dataset in order to perform the classification algorithms. So whenever people come up with new classification algorithms, they are curious to see how it will perform on the MNIST dataset, and anyone who learn machine learning tackle this dataset as soon as later. Okay, so here scikit-learn provides many helper functions to download the popular datasets. So one of the MNIST is one of the popular dataset. So scikit-learn automatically provides the some procedure to download the MNIST dataset. So here it shows the code shows the how you are going to download from the machine scikit-learn. So here from sklearn datasets import fetch openml. That means from the sklearn defaultly some datasets are updated. So they are going to download those dataset from the fetch openml. So here fetch openml is a one method, one class is there. In that we are going to mention the type of the dataset and the version name also you have to provide. So here our dataset name is MNIST-784. So here the dataset is stored in the download from the openml, and that is stored in the MNIST. And we are going to see what are different keys in the MNIST dataset. So for that, MNIST.keys. If you enter that one, automatically it shows the dictionary of keys, like what are different keys in the dataset, like data and target variables and feature names and describe and details, categories, URL, and also that means describe means describing the what is the data set, and the data key containing the an array with one row per instance and one column per feature. So a target key contains an array with labels. So that means here the target is there and the data is there. Okay, and here for example X and the data is going to divide into two parts. The data is going to divide into two parts like Mnist data and Mnist target. So here the column name is data and one more column is there target. So that data, the whatever the features of the data is there, that is stored in the X, and whatever the target variable is there, that is stored in the Y. Okay, so now the shape of the X is 70,000 images are there, 70,000 images are there, and each image size is 784. Each image size is 784. That means the size of the shape of the X variables are 70,000 images are there, 70,000 images are there, and 784 features are there. And the shape of the target variable is it contains only 70,000 columns, 70,000 instances are there. Okay, so here 70,000 images are there, and each image has 784 features. How? Okay, that means each image is of the size of 28 pixels and 28 pixels. Each feature is simply representing one pixel intensity. That means how we are going to represent the image. For example, the size of the image is represented in the form of a. The image is represented in the form of a matrix form. So each image is of size of 28 cross by 28. That means 784 features are there. 784 features are there. So that means the each image contains 28 columns and 28 columns and 28 rows are there. 28 rows are there. Now each pixel represents some feature. So now how we are going to represent all the features in a one row, one instant. For example, the image 5 is there. The image is 5 is there. So the image 5 is represented in the form of a image, in the form of graphical, in the form of image format is like so for example here the image 5 is represented like this one, okay. And now how we are going to represent this in the form of a one instance. Okay, for example here. So whenever we are having the our digit is there, that handwritten is there. So at that location we are putting the value as a 0, and remaining pixels are represented in the form of 255. Okay, that means it is a grayscale image. And whenever we are having the corresponding digit value there, that in that location we are putting the zeros. And remaining locations we are putting the value as a 255. 255 nothing but a white, and 0 nothing but a black. So after that, what happened? You have to represent all the pixels, all the 784 pixels in the form of a one single array, single vector. Okay, it contains 784 features, like 70 to 783 features. So in the first row, it contains all the 255. So like that we are putting all the 28 features into 255 values. And later we are having the 255. Okay, so 250 second row also represented in the form of 255. Okay, and third variable is represented in the form of 0. Okay, like that we are putting first of all we are placing all the first row instances in a single array, and then followed by second row instances, pixel values. Like that we are placing all the variables, so it contains 784, totally 84 features. Like that we are having the 70,000 images are there. 70,000 images are there, and each image contains 70,000 images are there. 70,000 images are there, and each image contains 784 features. 0 to okay, 1 to and so on. 783 features are there, and corresponding there is some class label there, that is a target variable there, like the name of the class label, like 5, 1, 2, 3, like that we are having things. This is about the overall view of the image, the Mnist data set. So now here we are going to see the 0 is nothing but a white arrow, 255 nothing but a black, or vice versa. We can use anyway anything. Okay, and take. So we are picking the how we are going to pick at one digit from the data set. Okay, now we need to do a grab an instant feature vector, reshape it to a 28 by 28 array and display it using the matplotlib image show function. Okay, so here we are going to import the matplotlib function. Okay, as we are replacing that is a rename as a mpl and matplotlib pyplot as a plot, and we are going to read the first row instance, all the first row instance, that is 0, x of 0. Okay, that is stored in the some digits. Now now we are going to reshape that entire image in the form of a 28 by 28 cross by 28. That means what are the 784 features are there? That 784 feature first row instance you are going to store in the x. Okay, some digit image, some digit variable. So now that is reshaped into 28 rows, 28 columns image, 28 rows and 28 columns. So what are the features of all things are there in the first row 0th instance, like 0 and so on. Okay, 783 features are there. All these features are converted into 0 to 28 by 28 features. Now by using the plot.image show, we are going to see the display that image. Okay, like after reading this, after showing this image, we are going to get the output as a that 5, that is a like a 5 image. Okay, so that means this is the image, like we are going to get the output. Okay, so now this looks like a 5 and indeed that what the label tells us. Okay, so here y of 0 is nothing but the corresponding class label of this feature is here we are having the 0th instance are there. These are the features. And the corresponding target variable is 5. That means this is a y and this is nothing but a x. The x we are having the all the 784 features of the 0th instance. Okay, based on that information, that is converted in the form of a 28 by 28 image, and the corresponding class label is 5. Like that, we are going to get the output of our image. Okay, the label is that is a string 5. So most algorithms expect numbers, so let's cast y to integers. So that means each and everything is in the form of a normally it is stored in the form of a string, but it's not a string. It is a numerical value. So it's a number. So we're going to convert that into integer. So y dot as a type np dot unit8, that is converted into string integer value. To give you a feel for the combination of the classification task, figure 1 shows the sum of the images of the Mnist dataset. These are the sum of the images of from the Mnist dataset. So now we are going to create a test set and set it as I said before, inspecting the data closely. So Mnist dataset is actually already split into training set and test set. Suppose that means while we are going to perform the execution of our machine learning algorithm, first of all you have to perform the training. Okay, and then we are performing the testing. So our data set contains 70,000 images are there. So these 70,000 images are divided into two parts. One is a training part and one is a test part. For the training part, we are going to have 60,000 images are assigned for the training purpose, and 10,000 images are assigned for the testing purpose. Now, so how we are going to split the data into two parts? That is based on the method called as these different ways are there to classify the data into training and testing. So here one of the thing is x train, x test, y train, and y test. That is equal to x of all the first 60 columns, 60 instances are there. That is assigned for the x train. These are assigned for the x train, and from that 60,000 onwards, what are the remaining variable instances are there? That is assigned for the x test, and what are the first part 60,000 target variables are there, that is assigned for the Y train, and from 60,000 onwards, all the remaining target variables assigned for the Y test. So like that, that means here we are having the data set is there, like so it divided into features, like these are the X and we are the nothing but a Y target variable, and that is this also called as a features, and Y is called as a target variable. Okay, it contains 0 to 70,000, sorry, 69,999, and up to 59,999 assigned for the training. So X to train. Okay, and first and remaining all are assigned for the X test, and the target variables are assigned for the Y train, and Y test. Too many things are assigned for the Y test. Like that, we are going to assign the all the variables, all the images, 7,000 images into for the training purpose and testing purpose. So the training set is already shuffled for us. So in order to perform the better, get the better accuracy, we require the we have to shuffle the data. So now here what happened now, the training set is already shuffled. Okay, which is good because of it is guaranteed that all the cross validation folds will be similar. So moreover, some learning algorithms are sensitive to the order of the training instances, and they perform purely if they get many similar instances in a row. Okay, so shuffling the data set ensures that this won't happen. So now we are going to see how we are going to execute the all this, how to read the data from the, how to import the data from the our data, SQL, and how we are going to read the data set, how we are going to perform the split the data into two parts. Like that we are going to see now. Okay, now I open our program in the Google Jupyter Notebook. Okay, here I am importing the our NumPy pandas, import as NumPy as NP, and import pandas as a PD, import matplotlib .pyplot as a plot, and import the scikit-learn. So the first step is we have to import the data from the sklearn. So that means we are to import the from sklearn dataset, import fetch open ml. So from this method we are going to import all the dataset. So here fetch open ml. So the name of the dataset name is mnst underscore 784. The version of the corresponding dataset is 1. So that is stored in the mnst. So we are going to see that what are different keys in our dataset. So it displays the dictionary underscore keys. So it displays data, target variable, frame, and categories, feature names, target names, describe and detail, and URL of the corresponding data set. Now we are going to divide the data into two parts. So that means X and Y. Here the X part contains the data. So here the features are the variables are data and target. The data is assigned for the X variable, and the target variable is assigned for the Y variable. So that means MNST is our data frame. From in the data frame, data is a one variable is there. So that what are the things are there that is stored in the X variable, and the target variable is assigned for the Y. Now we are going to execute that one. The shape of the X variable is X variable 70,000 images are there, and 70,000 instances are there, and 784 features are there. And Y for the Y shape is only it contains 70,000 instances. That means there is a single value is there. Okay. So now we are going to execute the X. Now it displays some of all the features of the that data set variables, like pixel value, pixel 2, pixel 3, like that. We are having the 784 features are there. Okay. Now it contains 0 to 69,999. Okay. So this is a one image. This is a one row image. Like that we are having the nearly 70,000 images are there. Okay. that means the size of the entire data set is 70,000 rows and 784 columns. Now we are going to divide the data into two parts, like for the training and testing purpose. Okay, so x is x and y is 70,000. Okay, so for example, I assign for the x is 60,000 and y is 60,000. So the shape of that one is 60,000 and 60,000 comma 700 features are assigned for the x, and 60,000 instances are assigned for the y. Okay, now we are going to see the sum of the one image of the entire data set. So here x lock, x allocation 0 to 1, that means the first row of the entire data and all columns of the data of the all the values are stored in the x digit. That means some digit is a variable that stored all the values of the entire first instance. Okay, now that is converted in the form of a reshape, reshape into 28 by 28. Okay, that some digit is that reshape is converted reshape into 28 by 28. That means it shows the corresponding 784 features in converted into the form of a 28 by 28 matrix form. So now we are going to display that that value some digit. Okay, now this is the one row, and this is the second row, and each row contains 28 features. So these are the all values are 0, nothing but a white value, and wherever we are having the 3 or some 127 to 45 like that, we are having the towards the black end. Okay, so here wherever we are having the 253, that means there is a some black pixel value there, that is that is our digit. Okay, so now I want to go to see the convert that enter these values into the form of a image. So that means we are going to use the plotting dot image show, and the shape of the image is some underscore digit underscore image that will show the plot dot show, that shows our image. Okay, that is a 5. Okay, now we are having what the label of this image. So y of we are going to see the target variable y of 0 that gives in the form of a, if you execute this form, we get the value as in the form of a string 5. Okay, then we are going to convert that into the form of a integer value. So y dot as type np dot integer 8, then it is converted the data in the form of a number of integer format. Now we are going to divide the data into different like x train, y train, x test, y test. So here we are going to see so the all the up to first 60,000 values are assigned for the x train, and remaining value up to first 60,000 target variables are assigned for the y train, and remaining all the elements are assigned for the x test from the 60,000 onwards, and remaining 60,000 target variables are assigned for the y test. Now we are going to test see the shape of the x train dot shape, y train dot shape, x test dot shape, and y test dot shape. We get the output as in the form of 60,000 images, and each image instance are assigned for the x train, and each image contains 784 features. And the first 60,000 target variables are assigned for the y train, and remaining variables are assigned for the x test, and remaining things are assigned for the y test. Like that, we are going to divide the data into different parts. In the next video, we are going to see how to train a binary classification. Thank you for watching our video. Thank you.